Alrighty, guys and gals, ladies and gentlemen, a couple more examples with our multi-step conversions for y'all to see. I didn't want to put this all in one video because it is a bit overwhelming. Though, yeah, it is technically possible for me to show you all possible calculations that you could see. There's too many to try and show you every single one every single time. The easiest way, like I said, use your tools. Use your map, find a way that helps it make sense to you. It's predictable patterns. The process is the same when you are switching substances and you have different units that are not moles. It's going to always take 3 steps. So on the screen right now, you actually see an updated version of the mole map. It includes the units and the constants. And I even added that little reminder note that I mentioned before about calculating the molar mass. And if that's not enough for you, then add a note to that molar mass. I got to add up my atomic masses. So I know we're going to be using the word mass here a lot, and you got to pay special attention. Is it atomic mass? Is it molar mass? Is it the mass of the compound? So this is our up-to-date map with the units and the constants. So volume is liters, and liters is always 22.4. That's kind of nice. My particles is always Avogadro's number, so 6.02 times 10 to the 23rd particles. And as I hope you remember, particles could be a variety of different things. You could see molecules. Delay response on my tablet, MLC is my abbreviation. You could see formula units, which I abbreviate F.U. You could see atoms. And yes, in theory, you could see ions. We're not going to see ions. We're not going to get that far. But, you know, later chemistry courses, you could be expected to calculate the number of ions in a particular compound. So my mass is the one number that's constantly changing. That molar mass is different for each and every substance, hence why there's not a number in that part of the island. So previous examples, I did mass to mass, and I think I did a particle mass. Now I want to look at, I don't even remember. I guess it's going to be mass to particles. Example number, if I've kept track, number 4, we're going from grams of NH3 to molecules of hydrogen. It's worded really badly. My brain can't handle English this late in the evening. So we're not going to worry about the fact that it's not grammatically correct. Instead, we're going to focus on the numbers and the units. The extra words are not important. Find the number, find the unit. I found my number, I found my unit. Now I got to find my other unit. My other unit is molecules. So I'm trying to find molecules, and it happens to be hydrogen. So I'm going to put hydrogen over here just so I have it together. So I'm going from ammonia to hydrogen. I'm switching substances. I'm switching units. That means I got to use my map. I'm going to be using 3 different steps to do this calculation. It's a 3-step conversion. This time I'm starting here on my mass, and I'm going to particles. The number that I give you in the problem is the first thing that we write. Grams of NH3 is what I start with. That means grams of NH3 has got to go on bottom. Grams of NH3 is the island that I started on. That means it had to go on bottom of my fraction. Whatever I'm going to goes on top. So whatever I'm going to moles, it's got to go on top. My cheat sheet reminds me that for this conversion, my mole is a 1. And for my grams, I remember I got to find my molar mass. And since this was what this, since this was in the previous video and not on the screen, what's my molar mass of NH3? Well, I've got 14.01 is the atomic mass of nitrogen, and I've got one of them plus 3 hydrogens, which gives me a total of 17.04. That is the molar mass of NH3. First fraction is done. First bridge is crossed. Now I'm ready to set up my middle step. My middle step in a multi-step conversion for us is going to always, always, always be that mole ratio, which makes your life a little bit nicer. Let me switch colors. Okay. My technology does not like me. Turn off, turn back on. Holy heck. Okay. Let's ignore the extra scribble. So we're trying to get rid of moles of NH3. That means it's got to go on bottom. The island I'm on goes on bottom. What I'm going to goes on top. My ending substance is hydrogen. So hydrogen moles has to go on top. I've got a mole over a mole. That means I'm using my coefficients. 2 on bottom, 3 on top. So last but not least, we've crossed that mole ratio bridge. I am now ready to go to my last and final step, which is particles. So I'm trying to get rid of particles. Not trying to get rid of particles. I'm trying to go to particles, and I'm trying to get rid of moles. So moles has to go on bottom because it's what I'm trying to get rid of. And particles has to go on top. This could technically say atoms. Our molecules, our particles. Oh, I said molecules. Bad Miss Rains. It's okay. They're interchangeable. So particles is what I'm going to. It's on top. That means my Avogadro's number is on top. And my 1 has to be on the bottom. Less messy version. Handy dandy calculator. You're going to get something in scientific notation. Depending on your calculator might show you something like this, 3.659, maybe some other numbers, and a big E with a 24. That E, don't write E in chemistry, we write times 10, and that 24 is the exponent. I hate the calculators that do that. I just know that they do. Don't remember which ones do, but if it's not saying times 10, but you still have something kind of funky at the end of your calculator, it's scientific notation. So, volume to volume example. I'm finding my number, find my unit. This says volume to volume. Okay. I just have a typo here. I changed the thing on top. Copy and paste was not my friend. Theoretical yield in liters of hydrogen. Apologize for the typo. So my mole map does not look like this because I didn't change my little pretty pictures. Volume to volume. I'm going from volume to volume. 3-step conversion. I'm switching substances. It is a 3-step conversion if I do not start with moles. The only reason it would be a 1-step doing a conversion with substances is if I'm going from mole to mole. First number that I write, 14.2 liters. I don't know why I was putting ammonia, but not ammonia. Since I started with liters, it's got to go on bottom. If liters is on bottom, my cheat sheet tells me that liters is on bottom, mole's got to go on top. And it's got to be a 1. Liters is on bottom, that means 22.4 has to go on bottom. Now here comes the part where we switch our substance. What I'm getting rid of goes on bottom. My starting substance has to go on the bottom in this middle fraction. My ending substance has to go on top in that middle fraction. We got a mole and a mole, which means I've got 3 hydrogens on top, 1 nitrogen on bottom. Last but not least, we're trying to get rid of moles because it don't ask for moles. It asks for liters. Getting rid of moles of hydrogen, going to liters of hydrogen. Since liters is on top, this time 22.4 goes on top. Since moles is on bottom, moles got to be a 1. Notice I didn't have to find molar mass. Unless you have mass or grams in the problem, you don't need to find that molar mass. And that's kind of a nice thing about this conversion. We're going to ignore the red line and the smiley face in the house. And do that because apparently this brains definitely cannot copy and paste. So handy dandy calculator, 14.2 divided by 22.4 times 3 times 22. I'm not using my fraction button. Assuming I did the math correctly, I get, dang it, 42.6. 42.6 liters of hydrogen. It's got its number, its unit, and its chemical formula. $14.2 divided by 22.4 times 3 times 22.4, just to make certain I didn't do something stupid. Okay, apparently I did something stupid when I typed it up earlier. That's okay. There we go. That's the one. That's supposed to be volume particles. Copy and paste earlier was not my friend. So we're ignoring the smiley face. We're going from liters to molecules. 1, 2, 3 steps. I'm using liters. I should have 22.4 liters on bottom. These are the only numbers that can go in my fractions. And I should get a number in scientific notation. I don't trust that I did it right a moment ago, so I'm going to double check my calculation. 22.4, 3 divided by 2 times parentheses 6.02 times 10 to the 23rd. Handy dandy calculator. Ooh. Oh. Yep, dyslexic moment. What in the heck? Oh, okay, I don't know what I did. 3.76511875 times 10 to the 23 is what my calculator gives me. General kids, give me a couple numbers after the decimal times 10 to the 23, and I'll be a happy chemistry teacher. Honors kids, we started with 3 numbers. We got to end with 3 numbers. My scientific notation does not affect the number significant figures. So 3.77, because that 5 tells me I got to round up. We raise the score, so my 6 becomes a 7 times 10 to the 23rd. So as y'all can obviously tell, Miss Rain's brain is fried from today. So yeah, have fun. There are other people, as I mentioned in the previous video, that are linked within the PowerPoint. Not PowerPoint, bad Miss Rains. The PDF document that's going to be attached to the Google Classroom assignment. We're working on these multi-step conversions for today and tomorrow. So you will have plenty of time to ask questions in class. I know for some of y'all, this is going to be really, really, really struggling through it. I need you to let me know when you're getting stuck. I can't just have you sitting there as a skittle on the screen, not asking questions, not communicating, not letting me know that you have no clue where I'm getting the 14.01 from. You have no clue where I'm getting the 3 from. So I need to know where you're staying, where you're stuck, where you're lost. As we're doing the conversions, don't forget, you can only change one thing at a time. I can change my unit or I can change my formula. I can't change both. That's why we're doing it step by step by step. You got to show your units, you got to show your formulas. Unless it's that mole ratio, your mole is a 1. And I deliberately don't put a number on my mole island just for that reason, because mole, sometimes a 1, sometimes not a 1. So if I'm crossing that middle bridge, it's my coefficient. Any other time, it's a 1. So my multi-step conversions, I end up with a 1 at the beginning and a 1 at the end. My coefficients are only used in the mole ratio, and that's it. They're not used with the molar masses. They're not used with the volumes and the particles. They're only used in the mole ratio. That number that I give you in the problem is only ever used once, always at the very beginning, and never, ever, ever in the fraction. There's only 4 possible moves. There's only 4 possible things that you can do. Grams to moles, moles to grams is 1. Mole to liter, liter to mole is 2. Moles to particles, particles to moles is 3. And last but not least, moles of one thing to moles of something else. We put those 4 pieces together, and that's how we got that nice, pretty mole map that Miss Rains showed out at the very beginning, and I'm having a hard time bringing it back up now at the very end. There we go. We put those pieces together, and we get a bunch of different possible equations going multiple directions, having various things that you can do, but take it step by step. Take it one little piece at a time. I can't sit down and eat a whole sheet cake in one setting, but if I take it one slice at a time, I can finish that whole cake. We take our conversions one step at a time, one fraction at a time, one calculation at a time, and you're going to be good to go. That is it. I am finishing off for the evening.